The James Webb Space Telescope is making some incredible discoveries, not just within our immediate solar system and neighboring galaxies, but from distant, faraway galaxies. Recent images from the jwst of the distant universe are shocking scientists. But what is so surprising about these new images? And what did astronomers and researchers find in these faraway galaxies? Let's find out in this video. Recently, astronomers have found a galaxy that has the potential to break cosmology. The recent images from the jwst of the galaxy reveal a mysterious object that, on closer inspection, was inexplicably massive and dated back to just 300 million years after the Big Bang, older than any galaxy ever seen before. The astronomers published a paper on the galaxy they called Glass Z13. So what's so amazing about this new discovery? Well, the extraordinary discovery of this galaxy, just weeks into James Webb's full operations, was beyond astronomers' wildest dreams. The Space Telescope is the largest, most powerful observatory ever launched from Earth, and was custom-built to revolutionize our understanding of the universe. Stationed 1.5 million kilometers away from earthly interference, chilled within striking distance of absolute zero by its tennis court-sized sunshade, the telescope's giant segmented mirror and exquisitely sensitive instruments were designed to uncover never-before-seen details of cosmic dawn. This is the scarcely probed era, no more than a few hundred million years after the Big Bang itself, in which the very first stars and galaxies coalesced. How exactly this process unfolded intimately depends on a witch's brew of exotic physics, ranging from the uncertain influences of dark matter and dark energy to the poorly understood feedbacks between starlight, gas, and dust. By glimpsing galaxies from cosmic dawn with James Webb, cosmologists can test their knowledge of all these underlying phenomena, either confirming the validity of their best consensus models or revealing gaps in understanding that could herald profound new discoveries. Such observations were supposed to take time. Initial projections estimated the first galaxies would be so small and faint that James Webb would find at best a few intriguingly remote candidates in its pilot investigations. Things didn't quite go as planned. Instead, as soon as the telescope scientists released its very first images of the distant universe, astronomers started finding numerous galaxies within them that, in apparent age, size, and luminosity, surpassed all predictions. The competition for discovery was fierce. With each new day, it seemed, claims of yet another record-breaking earliest known galaxy would emerge from one research group or another. So how exactly is James Webb looking at old galaxies and revealing new and interesting information? Well, one of the key science goals of Webb is to peer back in time and observe the early universe. Webb can do this because, like all telescopes, it is a time machine. Light travels at 300,000 kilometers per second, so when we look at the moon, we are seeing it as it was a second ago. As the planets of our solar system are millions or billions of kilometers away, we see them as they were minutes or hours ago. Going further off, when we look at distant galaxies with telescopes, we are often looking at light that has taken millions or billions of years to reach us. This means we are seeing these galaxies as they were millions or billions of years ago. When it comes to James Webb, the Space Telescope is capable of seeing more distant galaxies than other telescopes, including the Hubble. Like Hubble, it is above the glowing and turbulent atmosphere of the Earth. However, whereas Hubble has a 2.3-meter mirror for focusing light, Webb has a vast 6.5-meter mirror formed from 18 hexagonal segments. Finally, Webb is optimized to detect infrared light, which is what we observe from the most distant galaxies, as the expansion of the universe has stretched ultraviolet and infrared light into the infrared. Among the first data obtained by Webb were infrared images looking towards a cluster of galaxies called SMACS 0723. The light from SMACS 0723 has taken 4.6 billion years to reach us, so we are seeing it as it was 4.6 billion years ago. That's slightly older than the Sun and the Earth, which only formed 4.56 billion years ago. In recent weeks, galaxies far beyond SMACS 0723 have gained attention. Webb has detected a number of galaxies in the direction of SMACS 0723 and other regions that could be so distant their light has taken 13.5 billion years to reach us. Now, we say could because more data will be needed to absolutely confirm their distances, but some of these galaxies are very compelling candidates. As light has taken 13.5 billion years to reach us, we are seeing these galaxies as they were 13.5 billion years ago. The universe itself is 13.8 billion years old, so we could be seeing galaxies as they were just a few hundred million years after the Big Bang. While these very distant galaxies have been advertised as the oldest galaxies, You might find this a little confusing. We're actually seeing these galaxies as they appeared when they were very young, perhaps 100 million years old or so. It is true that these galaxies will be old now, but our own Milky Way galaxy is very old now too. While our Sun is 4.56 billion years old, many stars in our galaxy are 10 billion years old, and some stars in the Milky Way are 13 billion years old. Furthermore, the very distant galaxies Webb has spotted look very different today. Galaxies never stay the same and grow, acquiring gas and other matter over the years. So should we call these galaxies new or old? You let us know in the comments below. Thanks for watching.